Welcome to The Explainer. Today, we're talking about something you use constantly, maybe hundreds of times a day, from the second you wake up, but you probably never even think about it. It's the invisible language that runs our entire world. Seriously, just think about it for a second. From the moment your alarm goes off, you're interacting with a whole world of technology.
It's probably your phone, right? That little glowing rectangle on your nightstand. Before your feet even hit the floor, it's already connecting you to, well, everything.
And then you get in your car, which, let's be honest, isn't just an engine on wheels anymore. It's basically a supercomputer that also happens to drive, juggling your GPS, your music, and all those safety features at the same time. And this stuff is everywhere. I mean, it's even in your kitchen now. Your smart fridge could be adding milk to your shopping list while your smart speaker is giving you the weather forecast. So what's the one thing that connects all of this? Your phone, your car, even your fridge. Well, without it, they'd all just be, well, useless chunks of plastic and metal. That one fundamental thing is code. So let's dive in. Okay, so if code is the magic ingredient here, what actually is it? I mean, how do you talk to a machine and tell it exactly what to do? Well, the easiest way to think about it is like any other language. But instead of talking to a person, you're writing out super precise instructions for a computer. It's a language built entirely on logic. And here's what's really cool. It's not just one language. Just like we have English, Spanish, and Japanese, computers have hundreds of different programming languages. You'd use one for building a website, a totally different one for a video game, and another one for scientific research. There's a special tool for every job. So if code is a language, who speaks it? Who are the translators between our ideas and the machine? Well, that's where programmers come in. These are the folks who are fluent in these special languages. They're the ones who write the instructions, they solve the puzzles, and they literally build the digital world we live in. Yeah, think about that. They're like modern-day architects. Every single app you use, every website you browse, it exists because a programmer, or more likely a whole team of them, sat down and wrote it out, line by line. So how does that actually work? You can't just throw millions of instructions at a computer and hope for the best. There has to be a plan, a recipe, to turn all those instructions into something that actually works. And that recipe has a name. It's called an algorithm. Now, don't let the word scare you. An algorithm is just a step-by-step set of instructions to get something done. It's not magic. It's just a really detailed recipe. Let's look at a super simple example from your car. An algorithm is always waiting, and it says, if the driver pushes the engine status button, then show the status on the screen. That simple if-then logic, that is the absolute core, the DNA of almost all software. Now, that was a simple recipe, but these things can get huge. Even a basic app on your phone, one that seems really simple, can have thousands and thousands of lines of code, all built from these little logical steps. And then you get to the big leagues. To put this all in perspective, the code that runs all of Google's services, we're talking search, maps, Gmail, the whole shebang, is made up of more than 2 billion lines of code. 2 billion. That is, without a doubt, one of the most massive and complex things humanity has ever built. Okay, so all this code has to live somewhere, right? It runs on this giant global network. But here's something a lot of us get mixed up. We tend to confuse the network with the stuff that's on the network. So let's clear that up real quick. This is a great way to think about it. The internet, that's the infrastructure. It's all the roads, the highways, the physical cables connecting everything. But the web is all the stuff on those roads. It's the websites and apps. Think of them as the buildings, the shops, the destinations you actually go to. All right, so let's keep going with that city idea. Let's pick one of those buildings, a single web page, and look at the blueprints. What makes it look the way it does? Every single web page is built with 2 main languages. First up is HTML. Think of HTML as the skeleton. It gives the page its basic structure. It says, this is a headline, this is a paragraph, this is an image. It's just the bare bones. Then you have CSS. CSS is the close. It's all the style. It says, make that headline blue, use this font, and put that image over on the right. It's what makes the page look good. So to put it simply, HTML tells the browser what to show you, and CSS tells the browser how to show it. It's a perfect partnership. One handles the substance, the other handles the style, and that separation is what makes the web work so well. You need both. So now that you've had a little peek behind the curtain, what are you going to look at differently? The next time you open an app or search for something online, just take a second to remember all that invisible work. The billions of lines of code, the complex recipes, all of it working together just to make that one little thing happen for you.